Alright, so for 47, they're asking for g of f and the domain of the composite function. So this is your inside function, and its domain, look at this, is all real numbers. So we're coming in with all real numbers. So we're going to take the outside function. So g of f is square root, and we're substituting in place of the x, we're putting in f of x. So this is just basically x squared plus 4. Because it's inside a radical and there's a plus in between the x squared and the 4, x can be anything, because nothing's going to make x squared a negative 4, a number less than negative 4. So the domain for this is all reals. I know this is not in your review, but I do want to go ahead and show you if they asked you for f of g and domain, then the g is the inside function. So you would take the f and substitute in place of the x the square root of x. So this would be x plus 4, and that would be the function f of g. Now at first glance it looks like the domain is all reals, right? But remember, g is the inside function. We came in only with positive numbers greater than 0. Okay, so the domain is the same. Like that. Alright, for number 48, we're doing g of f and the domain of the composite. So this is your inside function, so we're coming in with this domain right here for this one. So we know that x cannot be 0. Okay, so now the g is the outside function, so that's this one right here. So we're going to put plus 5. We're going to substitute the x with f of x. Okay, and we're going to combine the two together. The common denominator is x, so that means that this one gets multiplied by x over x. So now I have 1 plus 5x over x. This is g of f of x. Domain is still all x such that x cannot be 0. Okay, the numerator doesn't matter because x is not inside a radical. So we just, there's no restriction on that, just on the denominator. Okay, for number 49, they're asking you to find the inverse. Okay, so let me erase that and start off here on the side, 49. There are 4 steps, they're in your notes. Find the inverse of the function. First off, we're going to change g of x to y. And as it is, x squared minus 3 is a parabola with a vertex at 0, negative 3. As it is, it's not 1-to-1, so it has no inverse, because it's not 1-to-1. No inverse function as it is. Okay, that's there. Okay, 50. Find the inverse. Now notice this is another parabola, but here they do restrict the domain. They're saying pick all numbers x greater than or equal to negative 4. So this one, number 50, is a parabola that goes like this. And so they're just saying pick the part where x is greater than or equal to negative 4. So just pick this half right here and find the inverse of that half. And the pink part, that one is 1-to-1. So we could find the inverse. Okay, for 49 we couldn't, because this is the whole parabola and it's not 1-to-1. So 50 we could. So first thing we're going to do is change the f of x to y, and then x plus 4 squared. Then we switch the x and the y, switch places, so x equals y plus 4, like that. Then we solve for y. So we want to get to this y right here. First thing we could do is take the square root of both sides. And remember, when you take the square root, you're going to put plus or minus square root of x equals y plus 4. But because we're looking at the right side of the parabola, we're picking the positive root. Okay? So we're no longer going to put plus or minus. We're just going to put square root of x equals y plus 4. Subtract 4. And I'll just continue right here. So y equals square root of x minus 4. Now be careful, the minus 4 has to be outside of the radical of the square root. And then the final step is to switch over the y to inverse notation. So it would be f inverse of x equals the square root of x minus 4. So this is the inverse of this one. Okay? So 51, we are finding the inverse of the function. So step number 1, change the f of x to y, replace it. Step 2 is switch the x and the y. And then solve for y. So in order to solve for y, we've got to get the y out of the radical. So what we're going to do is we're going to square both sides. And so I get x squared equals 7y plus 8. So then I subtract 8. So I get x squared minus 8 equals 7y. Then I'm going to divide by 7. Okay. And so now I have y by itself, right? So I change the notation. So f inverse of x equals x squared minus 8 divided by 7. Okay, and so here's my inverse right there. Oh, I almost forgot on number 51. You have to indicate that x has to be greater than or equal to 0, because otherwise this parabola wouldn't have an inverse. It's something like that. So it wouldn't have an inverse, so you have to say that x is greater than, so we're only looking at the right hand side. That's 1 to 1. So that's a restriction, you have to give it. Okay, so for number 52, find the inverse, so change the f of x to y. Switch the x and the y, and then solve for y. So we're going to add 9. So x plus 9 equals y to the 5th. And how do you leave y by itself? You take the 5th root of both sides. So 5th root of both sides. That. So now you're left with 5th root of x plus 9 equals y. So then just change the notation to inverse. So f inverse of x equals the 5th root of x plus 9. Okay, and this one you don't have to put a constraint on x because the index is odd, so you know it's a 1-to-1 function. Okay, that's it. Number 53, sorry, I read 54. Number 53 is you already have the y, so just switch the x and the y. And solve for y. So what I'm going to do is I'm going to multiply both sides by y. So that cancels it here. And then I'm going to go, so this leaves me yx equals 1 over 8. So now I'm going to divide, or actually I should say, to make it easier, I'm going to multiply by 1 over x, multiply by 1 over x. So So here the x and the x cancel to 1, give you 1, and I have 1 over 8x. So this is one of those cases where the inverse and the function are one and the same. This is the inverse. Notice it looks exactly like the original. So when you graph the inverse and its function, they're exactly the same. And that happens.